Hi there, welcome to Chapter 1. All right, so we're in Chapter 1, we're going to be looking a lot at equations, and so we start off with looking at graphs of equations. And so some of this we have seen, and some will be a little bit of new stuff. So we're going to start off and just pick out a few things. One of the things we're going to talk about today are the x and y intercepts. When you're looking at a graph, the x-intercepts are where your graph touches the x-axis, y-intercepts where it touches the y-axis. We're going to look at these both algebraically and how you can find them on a graphing calculator. All right, so a lot of what we're going to do today, I'm going to assume you know how to use your graphing calculator. If you don't, and today I'll give you just a quickie, here's where you go. But if you're iffy on anything, I have special videos specific to how do you find this on your calculator, how do you find this. So go back to the spreadsheet of all the videos and you'll see it at the top, some specific graphing calculator helps. Okay, so let's start with, when you're looking at a graph, when you're looking for the x-intercepts. Okay, so if you're doing x-intercepts, then algebraically, what you do is you're going to plug 0 in for y. And if you were doing the y-intercepts, you would plug 0 in for x. By the way, I don't have a note sheet for this section, so you're kind of, on some of these lessons, the last chapter P, I had note sheets for everything. This, you're on your own, creating your own notes. Okay, so if you think about this on a graph, and you had some sort of something, whatever it is, all right, if you have x-intercepts, notice that on the x-intercepts, you're not up at all, so the y value should be 0, so that's why we're plugging 0 in for y. And if you'll notice your y-intercept right here, you're not left or right at all, so that ordered pair would have a 0 for x, which is why we're plugging 0 in for x to find the y-intercepts. That's where that comes from. Okay, so we'll come back and do an example. Right now we're just taking notes on how to do these things. If you were looking on your graphing calculator and you were looking for your x-intercepts, okay, there's another name for that. We call those the zeros. And so to find the zeros, you go to second trace, which is a calc menu. And at second trace, you're going to look for zeros. And this is the one where it comes up and it wants you to kind of surround the zero. So you're going to go a little bit left of the zero, then a little bit right of the zero. You press enter through the guess and you have it. All right. The y-intercepts on the graphing calculator doesn't really have a specific place to find the y-intercept, but since you're going to plug 0 in for x, one of the places that you could go is, again, second trace, but this time you're going to go to value. And all you do is you type in whatever x value you want, and it'll shoot you back the y value. So in this case, you would plug 0 in for your x value, and it'll shoot you back what the y value is for that, which would be then your y-intercept. Now you can also go to your table if you want, and if you're familiar with the table, that's another place to find where the x is 0 and the y value that goes with it. Okay, so let's try an example of this. Okay, so I have our equation, y equals 6x squared minus x minus 12. So let's first of all, we're going to look at them algebraically, then I'll have you try it on your calculator. So to find the x-intercepts, remember you plug 0 in for y. So I'm going to plug a 0 in for y, and this is something that we did in chapter P. It's a nice quadratic. We should be factoring on this example. So it looks like it'll be a 2x and a 3x, and then I'm looking for factors of 12. Could be probably 3 and 4. Looks like a 4 there and a 3 there. That gets me an 8 and a 9, which is a difference of 1. So I want my 9 to be negative. So I'll have a minus there and a plus there. Now since this equals 0, remember that you set each of these equal to 0, and then go solve them. So if I add the 3, divide by the 2, I have 3 halves for one of my x-intercepts. And over here I'm going to subtract the 4 and then divide by the 3. So the other x-intercept I have is negative 4/3. So I have two x-intercepts. Okay, so to confirm that on my calculator, what I would do is begin by typing this into my y equals. I'd probably just do a zoom standard window. And then if you do that, you might find that you have to open your window up a little bit on the y min and let it go a little bit lower so you see the full graph. Probably if you just did a zoom standard, you'd see something like this. It would come down, and you're going to see that, and then it's going to do this because you're just not quite low enough. If you open that up to about a negative 15, you'll see the full parabola. So now what you're going to do then is you'll do second trace, zeros, go a little bit left of this x-intercept, and then go a little bit right of this x-intercept. Press enter through the guess, and it should give you that value right there. And that should be a negative 4/3. Do the same thing for this side. So what you'll do, now these aren't too bad. They're not quite as pretty as what we did the other day, but you are going to find more and more that these intercepts are not nice, and it's not like you can just look at the graph and tell. It's going to be some ugly decimal. You got to use your calculator to find it if you're not doing it algebraically. Okay, let's now go over to y-intercepts. On y-intercepts, we plug 0 in for x. So I'll have a y equals, and then I'm going to have a 6, plug 0 in for x, and then simplify. So this is just going to become 0. This is minus 0. So all I have left is this minus 12. That actually works pretty quick and easy, faster than even doing it in my calculator. Okay, if I was going to check it though in my calculator, I would go to second trace, value, plug 0 in for x, and ideally you get this back for your y value. Okay, so be able to find x-intercepts both algebraically and on a graphing calculator. All right, the next thing we're going to look at is symmetry on our graphs. Now, you know a little bit about symmetry from geometry, and you would have learned probably things like you can have a line of symmetry through a triangle or something like that. And basically, it just means that you can fold that over and it lands on top of itself. Okay, so what we're looking at is not geometric shapes, but graphs on the coordinate axis and what type of symmetry they might have. There's three types of symmetry that we look at. Let's start with just the y-axis symmetry. Let's sketch a little picture of what that might look like. If we were to have y-axis symmetry, then that would be something like maybe a parabola. That you can tell that that would fold nicely over this y-axis, and one half of the parabola lands on the other half. Okay, so if you do that, you get I'm just going to make up a point out here. I don't know what it is. I'm going to call it x comma y. Can you figure out what this matching point over here would be? Go ahead and jot down. What do you think we could write for that ordered pair? All right. Since it's symmetrical, if you fold that over, you're going to have to go the equal distance to the left that you did to the right. So it'll be a negative x, still going up y. So if a graph is going to have y-axis symmetry, and some point, whatever it might be, works in that equation, then you should find that a negative x, y will also work in that equation. All right, let's look at x-axis symmetry. Same deal. Come up with a graph, probably like a sideways parabola would be a nice example of something with x-axis symmetry. And you can see that that would fold nicely over this x-axis. So let's grab a point up here. Let's call it xy. What do you suppose its matching point down here would be? All right. We're still going over the same amount, but instead of going up, we're going down. So the other point would be x negative y. So if you have an equation that has an x and a y, then you should find that if you have an x negative y, that should also work. In other words, if you change the value of the y to a negative, it doesn't matter. You're still going to have the same x value. Okay, last type is origin symmetry. And origin symmetry is a graph that looks the same if you look at it upside down. A nice classic example would be a cubic. Okay, if I call this my xy, what do you think that point down there would be its matching point? And since you're now going left and you're going down, so if you change the x to a negative, it's also going to change the y to a negative. Okay, so that's great looking at a graph. Let's look at an equation because that's really what we're going to be doing. All right, so I have several examples here. And what we're supposed to do is take each one of these equations and decide if it would have y-axis symmetry, x-axis symmetry, or origin symmetry. All right, so in other words, what I'm doing is I'm looking to see, well, let's go back for a second and notice just the kind of the pattern here. If you're looking for y-axis symmetry, the x doesn't matter if it's positive or negative. If you're looking for x-axis symmetry, then the y can change signs and it doesn't matter. So keep that in mind. It always does the opposite letter. Origin will change both. Okay, so when I'm looking at these equations, I'm kind of figuring, well, what's going to have to happen for that negative to not matter? Well, here's what I think of when I look at that. Think about what 4 squared is equal to. And that's just equal to 16. If I have a negative 4 and square it, what's that equal to? 16 still. So it doesn't matter if it was a positive 4 or a negative 4, I still get 16 because I squared it. So anything that's squared, or really to any even power, would make me think, okay, it doesn't matter if it's positive or negative. Another thing that might do that is like an absolute value. It wouldn't matter if it's positive or negative. The absolute value would go back to the same number. So you're looking for some kind of feature like that in your equation. So when I look at number 1 here, I see that squared. So I'm thinking, well, since it's the x squared, it probably doesn't matter if my x is positive or negative. So if I look at my 3 options, this is the one that says, hey, it doesn't matter if x is positive or negative, you're going to get the same y value. So let's check y-axis symmetry. So you may end up checking more than one method. The idea is that you check every method until you find one of them to work. But I'm going to be smart about which one I start with. Okay, so in this case, I think I want to test my y-axis symmetry. So what I would expect to see then on your homework is saying, all right, so here's my equation. If I plug in a negative x for the x, let's see what happens. All right, take your negative x, you square it. Well, that's just an x squared minus y equals 0. And then I go back to the original and compare it and say, oh, look. It's the same thing. So it didn't matter that I put a negative x in. I got the same y value back. So we would call that y-axis symmetry. Okay, turning sideways because I'm going to run out of room before this is all said and done. Okay, let's go to number 2. All right, so on this one, it looks like the y is being squared. Okay, so then I go back up to the top and say, which one does it look like it doesn't matter whether the y is positive or negative? And that looks like that would be x-axis symmetry. If I change the y to a negative, the x's still stay the same. All right, let's give it a shot. So I'm going to have x equals. I'm going to put in a negative y instead of a positive y. And then I'm going to simplify it up, get rid of parentheses. That's going to turn positive y squared minus 8. Go back and compare. Oh, looky, it's the same thing. All right, so it didn't matter if I had a positive or a negative y. I got the same x. That is definitely x-axis symmetry then. So I'm going to write x-axis symmetry. And that's what we're doing. We're just testing what type of symmetry that equation might have without having to actually graph it. Now, they won't all be quite that straightforward. If you look at number 3, yes, I have an x that's squared, but the problem is that I have another x in this problem other than that one. I also have a fraction, which might throw a twist in it. So they can do different things to this equation, and it might affect what's going on. So which one do I start with? Well, I probably am still going to look at that squared and think, let's change the x. So I'm really doing a test here for the y-axis symmetry. putting in a negative x for every x. So that means even on top. Okay, so that would simplify to, I'm kind of out of room, I'm going to have to go horizontal here. All right, so I'm going to end up with a y equals, now, well, okay, so it'll be a negative x over, and I end up with a positive x squared plus 1. Okay, so when I look at this, one of the things I want you to note, coming back up here to the top, look at, if I were to say something like, hey, I got this fraction, it's a negative 1/2. Would you agree that it doesn't really matter where I put that negative? I could also put it on the bottom, like that. It's still a negative 1/2. But more importantly, I could pull it out in front, and it would look like that, and it would still be a negative 1/2. Okay, so here's what I'm going to do. I'm going to take the negative that I have right here, and I'm going to pull it out in front. So I'm going to do some erasing and cleaning up here. All right, so I pulled the negative out in front of this fraction, and so now I'm going to go look and compare that to what I started with. All right, so I've still got the x on top. I've got x squared minus, oops, I'm sorry, it was a, I wrote that wrong. Did you catch that? That was a plus sign. I was supposed to have plus sign. Okay, and so it looks exactly the same, except that it's the opposite of that whole fraction. Okay, so what I did is I changed the x value, but what happened is I got the exact opposite y value because of that minus sign right there. So if you look at your three options up here, which one, when you change the x, it also changes the y? And you should see, oh, that happens on origin symmetry. So this one ended up with origin symmetry. All right, last one. Let's try number 4. Okay, so this one's weird also because now it has this square root in there. But again, if I see a squared or an absolute value, that's probably what I'm going to start with. So I'm going to test my y-axis symmetry again, thinking if I change the x, it shouldn't matter because the x is being squared. So let's try it. Y equals square root 4 minus, putting in a negative x here, squaring it. So y would equal square root of 4. Now I got to do my squaring, so don't go thinking you're going to do change there to a plus plus. Don't do that. It's a minus. Then I got to square this. It's going to be x squared. And then I come back and compare it. And lo and behold, there it is, exactly the same thing. So I changed my x, but got the same y value back. That's a y-axis scenario right there. Okay, folks, there you go. That's what you're kind of doing on those problems. All right, the last thing that I want to talk about today is circles. Now, think about what type of symmetry a circle would have. So if you had some sort of graph up here and draw a circle, okay, does that reflect nicely over the y-axis? Yep. But does it also reflect over the x-axis? Yep. Does it look the same upside down? Yep. So really a circle has lots of types of symmetry. Now, on the problems that we're doing on symmetry, I kind of picked out ones that only have one type of symmetry. So if you can find one of the 3 types, you're good to go. Circles are going to have a lot of symmetry, so I'm not really going to ask you about symmetry on circles. Let's talk about some other things with circles. Okay, so from geometry, do you remember your equation? If not, you should probably jot that down. All right, so you're going to throw some numbers in here. This h and k, these are going to be numbers. This r squared, that's going to be a number. And what this hk tells you is what your center is. So whatever number you see here, notice the sign is different. It's a minus h, but the center has a positive h here. All right, so this is basically the opposite of the x coordinate. This is going to be the opposite of the y coordinate. And then it equals r squared, or my radius squared. So with that idea, we should be able to give you an equation, and you pick out the center and radius. Okay, so on this example, the center, if you look at what's inside the parentheses. It's a minus 8, so I always do the opposite. It's going to be a positive 8. And the y value has a plus 1, so I'm going to put in a minus 1. And that's the center of my circle. So if I were sketching it, it would be over 8, down 1, somewhere like right there. Okay, the radius, remember that the equation is equal to the radius squared. So if I square root this number, I would be back to r. So it looks like my radius is 3. If I were going to graph this, I basically, from the center point that I found, I'd go up 3, plot a point, down 3, plot a point, right 3, left 3, get 4 points, and I could sketch my circle there. Okay, let's try one where we go the other way. What if I give you the center and I give you the radius? Could you write that equation? Okay, ideally you say, sure I can. All right, so we're going to put it in parentheses, x, and it's minus h. That's my x value, but remember you always do the opposite. So since this is a negative 2, I'm going to end up putting in a plus 2. Squared plus, now let's do the y's. It's going to be a y, and the y value of the center is a positive 5, so I'm going to put in a minus 5. Squared equals the radius squared. So if the radius is 4, r squared would be 16. There's the equation of the circle. Okay, this is all stuff that you would have done in geometry. Let's try something that's just a hair harder than what we did in geometry. We're still going to be using that equation of a circle. All right, but I'm not going to hand you the center and the radius every time. You're going to have to do a little bit of thinking. So it says, write the equation of a circle. With endpoints of the diameter, 2, 3, so over 2, up 3, somewhere like right there-ish, and 6, 9, somewhere up there-ish. Those are the endpoints of the diameter. So my diameter would look like this, which means my circle looks something like this, I guess. All right, they did not say, hey, here's your center. They did not say, hey, here's your radius. I don't have anything there. Well, I have something, but not what I want. All right, so let's use what we learned in Chapter P. How do you suppose we could find the center of that thing? Well, yeah, duh, it'd be the midpoint. Okay, so the center is the midpoint between those 2 points. So you should be using your midpoint formula. Remember, on the midpoint formula, you're going to add your x's, 2 plus 6, divide by 2. Then you add your y's, 3 plus 9, divide by 2. All right, so that ends up with 8 halves and 12 halves, which comes out beautifully. Don't expect it to always be quite this nice. 4, 6. Okay, let's check that over there. 4, 6. Yeah, that seems probably reasonable for that point right there. So now I know the center. So I wrote M for midpoint, but that's really going to be the center of my circle. All right, so now I have to find the radius. Now the radius would be this length right here, or this length right here, either one of those. And so if I want that length between this point and this point, I'm going to find the distance between those two. It doesn't matter whether I use this point or this point. And sometimes, now this one they said these are the endpoints of the diameter. On your homework, sometimes they'll just call it a solution point. A solution point is some point that falls somewhere on the circle. Could be anywhere. All right, so I'm going to find the distance between the center and this point over here, because that would create a radius. So the center is the number I just found, 4, 6, or not number, but the coordinates. And I'm going to pick out 2, 3 as my other point, and let's go do distance. Remember, distance formula is going to be x minus x squared plus y minus y squared. So that's going to be 4 minus 2 is 2 squared. And then 6 minus 3 is 3 squared. And so that ends up being the square root of 13. Now remember, that's the distance, or really in this case, that's my radius. So now I'm going to write the equation of my circle, now that I know the center and I know the radius. So the center goes x, remember opposite sign, so it'll be x minus 4 squared plus y minus 6 squared. And it's going to equal my radius squared. Well, if I have the square root of 13 and then I square it, the square and square root go away and I get 13. So there's the equation of my circle, using a little bit of that math that we learned previously. All right, good luck with this.